So welcome to day 2 of Learn AR Weekend. Today we're going to cover some interactive elements, a little bit of scripting and stuff. Before we get into the AR stuff, we are going to kind of do a little example project, some cubes, some spheres. And basically what I want to cover first is I want to show you how you can move stuff in scripts based on input. So we'll do some basic keyboard input. You press a button, something moves. So like if button press, then move type stuff. And I'll also teach you how the scripting kind of like fits into the whole Unity like actual interface, the components, the scene view, and all that stuff, and you'll get how like the words actually correlate with what actually happens in 3D. So it'll make a lot of sense. And so let's just go ahead and open up Unity, and we're gonna start. Actually, we might even be able to open up that old project that we had. Should be that first one that we did, just Learn AR Weekend Day 1, where we kind of did our spheres and like stuff that we were kind of doing on day 1. So we can kind of work from that. So it should be like the one right before the AR kit one. So if you had everything titled correctly, it should have just been like, should be this project that we were doing at first. Yeah, you probably didn't. Just go to File, Open Project, Open Project, I think. And then it should be this one.
Oh.
The one right.
Oh,
Yep.
non-AR. Okay, yeah.
Yep. Did you find yours? Okay, great. So this is we're kind of comfortable with all this stuff here that we already have. So the first thing that I think is kind of important to explain is just a little bit of how the coding works with components. So we had kind of gone in and explained that when you click something in Unity, kind of brings up this inspector here on the right, and we kind of mostly covered the transform component, and we did a little bit of the rigid body. You add a rigid body to something and it has physics. So like I said in the beginning of the class, everything in Unity is component based. So it's game objects, and game objects have components. The component that every game object has is a transform, and that's the one that we're actually going to work with first in scripting because it's the simplest one to understand, and that is like moving that X, Y, and Z that we were showing earlier, but moving this in code. So this is a type of scripting that's basically going to just simulate movement in a sense. You can find this kind of movement like in games or whatever, and if you think about like how a game works, is something moves based on something that you press. So you press, something moves. You hold, it keeps moving, and etc. So we're going to kind of explore a little bit of how you get that press, like how do you check for what's pressed even, and then how does something happen after something is pressed. So what we're going to do is, we can kind of just leave all this stuff alone here. And what I want you to just make sure is that your main camera just kind of has a nice, maybe like if you're really kind of up here, maybe just move it back a little bit just so we can kind of, move away from all this stuff that was going on here. And again, like if you're screen recording, the Mac tends to heat up after a while, and it might get a little choppy frame rate. But just kind of bear with it, or turn off the screen recorder if it gets too unbearable. I'm just gonna keep mine on because you'll need to have this later. So what I'm gonna go ahead and do right now is we're gonna make like a new object. I'm gonna go to Game Object, 3D Object, Sphere, and again my sphere just kind of popped up under the ground. It's totally normal. It kind of does it on of its own accord. So just reset its position to 0, 0, 0, and then just kind of move it, so it's kind of like in front of the camera like this, and then pull it out of the ground, just like so. It'll be very simple. If you want, you could put some materials on that sphere that you maybe had from before, maybe like a marble material or whatnot. So, but it's totally optional. Don't have to do that. So yeah, let me know when you have the sphere nice and positioned like that in a place where we can see it pretty clearly. Right. So, in order to create a script that's going to make an object interact, what we're going to be coding in is C#. Now, Unity does have what's called Unity script, which is basically, in here it's called JavaScript. But like, it's not really JavaScript. It's Unity script. It's just kind of like a custom programming language that Unity made. It's very much just like JavaScript. JavaScript is easier for beginners, but you'll find that very fast, like you'll basically be very limited in how much you can do with it, because everyone online and all the examples and all the Unity assets and everything uses C#. Now, you can use C# and JavaScript together in a project. It actually works. One object could be running a JavaScript and another object could be running a C# script, and Unity will not have problems with that. But you cannot share data between the JavaScript and the Unity script. So it's best to kind of work in one, and the one that I recommend and that generally is recommended is to do it in C#. It's a little bit of a more like defined language. So like what I mean by that is like in JavaScript, and we'll kind of explain what these also mean. There's different data types. There's like integers, there's text, like strings, they're called strings. Then there's, instead of like an integer, there's what's called floats. And floats are basically like decimals. They're not like integers or like whole numbers. Decimals, point something something. But a float is like, it's not just a decimal, it's like a float can go very precise, like 0.1100003655 or whatever. And that's kind of like what you see when you click an object and you move it. You see how the position, it's a float value. It's like position in X, Y, and Z space. It's not integer based. Everything is based on this, what's called a floating point. So again, I'm not gonna try to burden your mind too much with this computer science stuff, but it's good to kind of at least understand it. So if you think about it, like in 3D space, if you have this Unity coordinates, like 1, 2, 3, 4, whatever. If you're moving like in integers, your object would probably be hopping like this, right? Which is not, it's not a fluid motion. So in order to get that fluid motion, CPUs have specific, so computer processors have specific transistors just built. They have entire like sections dedicated to floating point calculations, so which are very different from just regular integer calculations. So it needs to be able to increment so small to a point where that's called a floating point. It's I don't know like how many decimal points further down, but basically that's what gives you that fluid motion of everything in between that 1 and 2 or 3 or whatever. So that's kind of how it works. Now, I got that kind of out of the way. I'm also, I'm going to get back into the data types again and what they are and what the major ones are. But we can just kind of go ahead and just make our first script. So the way that we're going to do that is you're going to right-click in your project to basically just add a new asset. We're going to right-click, create, and then right here at the top it should be C# script. Now, right before you see it, it kind of lets you name it. So this is important. Like you should not like save it as new behavior script and then rename it later. And I'll show you why. Because basically inside the script, it sets itself up to work with the specific name. So sometimes a beginner mistake is just to make a new behavior script and then I tell people like, no, name it to ball move script, and then they go in and then they change it to ball move like that, and then what you're gonna get is pretty quick. You're gonna get an error. Watch if I press play. Wait, it needs to. I think if you put it on something, it'll give the error. Yeah, so like say you put that script onto the sphere we just created. Oops. Can't add script because script class cannot be found. So if you double click the script, you can see that in here it sets itself up with just a bunch of, so it's going to open MonoDevelop. It sets itself up with just this kind of like structure, which is basically just a simple class. And you see the class is still called new behavior script. So basically it sets itself up with whatever that initial name you give the script. So if you wanted it to work, the name of the class needs to be exactly the name of the file. And that's that beginner mistake that a lot of people make. So to avoid that, just when you create your new script, name it right away. And then it'll set itself up properly. So just as long as that's kind of like cleared up. But yeah, make your script called ball move. If you had already made it called new behavior script, you can rename it, double click it, open it, and then go in here and make sure the class is also called the same as the name of the script. Now, caps are important in scripting. So if a letter is capitalized, that's important. It's different from a letter that's lowercase. So if M here was lowercase, it wouldn't find it. So it needs to be exactly like uppercase letters where they're used. So let me kind of break this down now, what this kind of looks like here. So all this stuff up here at the top, using. So using is like something that's been brought in from older C languages. So like way back in the day, it just C. I mean, I might be wrong on this. I'm not like, I never really did C like that or whatever, but just from the little computer science understanding that I have, it's like C was a very raw language, and you didn't really have libraries in a sense like you do now. So like everything that you did, if you did like some vector math, if you were doing some scaling, if you were doing some, I don't know, like time calculations or whatever, everything was kind of like done, like you had to write it. Like everything was, you literally worked in just pure math. It was like multiplying, dividing numbers, and like percentages and stuff. Everything was kind of like just the basic stuff. But in more modern C languages like C++, and then the newest one now is C#. So that's like the supported one by Microsoft, and everything that you write in Windows, Windows applications are C# mostly now. People still write C++, but C++ is mostly for really low level like DLL files and for like graphics stuff, and for very like where you need like to allocate your own memory and stuff, and like we don't do any of that in Unity, so that's good. So we don't actually have to worry about memory leaks or any of that kind of nasty stuff that like typical programming has to worry about. So C# kind of cleans that up for you. So the using is basically brought from this library structure where you have a whole set of what are called functions built into Unity. So things like move to point, things like local scale and world scale, things like look at, are things that are already designed and perfected. There's only so many ways you can write a look at script, and instead of you having to rewrite the logic for look at, in Unity you'll just do object.lookAt, and then it looks at something. So it's kind of simplified, and it kind of comes with lots and lots of like functions and libraries. So that's what this using does. And I'll just break these down because these are the ones that you see always in every script that comes. So using system collections and using system collections generic are basically generic like Windows level, like Mac level, like C# level scripts. So those do things like managing lists. Sometimes you'll have lists of objects and stuff. Those things will do a bunch of like kind of like low level operating system stuff. And again, like, you know, if this stuff is like way over your head, don't even worry about it. We're actually not ever really going to touch this for the most part. But I just like to explain it because I feel like knowing is important. And then using Unity Engine is the one that's all of the Unity level functions get brought in, like look at and move to point and some other interesting stuff like that. So for pretty much like 90% of the stuff that you're gonna do, it's all gonna be set up like this. And you know, it's not really, you're never gonna not use Unity Engine. Only later, when like, you know, years later when you really get like good at coding, if you do choose to kind of go deeper into it, will you maybe make some scripts that don't use the Unity engine? It's just some abstraction class, and you can then not have to use it, and just you make your own classes basically at some point. But we won't be doing that anytime soon. So it's just good to understand though. So then let me break this other part down. So basically everything kind of starts like this, as a public class, and then that's basically the whole encapsulation of the script. And it's called ball move, and you got this colon, and it says mono behavior. So mono behavior is basically all of the behaviors that happen in Unity are a type of mono behavior. So you'll notice that your program is called mono develop, and mono is something that came out before Unity. So mono is basically, not the disease, this always happens. And whenever I do these classes, like, that was like mono, and then it's just like some mono disease. It's like, okay. So mono is a cross-platform open source .NET framework. So basically, Unity built its framework on top of this framework because it's basically made, you code in mono, and you export to Mac, to Windows, to mobile, to everything. It just kind of like, it cross-compiles. So what that means is like compiling is basically you take human readable English code and turn it into machine zeros and ones. So mono does that. And that's why you'll see mono around Unity. Mono develop, mono behavior. It's all kind of built from this open source mono framework. So it's, you know, sitting on the shoulders of giants like this. This is like, Unity did a lot, but there's also a lot done before them, and a lot done before the mono guys with C++ and C#. And so, you know, we're at a point now where we have it, all the tools are at our disposal, and it's like been made much simpler than it used to be. It still like is a little tricky for newcomers, but if it's just explained in the right way, it won't be as scary. So it's actually pretty simple when it gets broken down. So that's what this means. So then you'll notice that everything kind of uses these curly brackets. So we call these curly brackets. And you always open a curly bracket and you close the curly bracket. So you'll notice when I click one of the curly brackets, when I put my cursor there, that it shows me where it closes. And when I click the closed one, it shows me where it opens. So that's just a quick little like way for you to know where they're open, where they're closed. If by accident you forget to close one or something, you will get an error. And if I just go back to Unity, see right there, error, unexpected symbol end of file. And it's going to tell me even the line, it's at 16. So if I double click that error, it'll basically, it should open up mono and just tell me where that error is. I don't know why it's not doing it for this one. Should do it. It does it for some other things. I guess for the end of file thing it doesn't, but it tells you, see, it kind of highlighted it already, I think. But it tells you, yeah, see, now it's not highlighted, but if I double click this, see, it highlights it. In Windows, it will like pull up the window. I guess in Mac it doesn't pull up the window always, because it's just, I don't know why it doesn't do that. But if you had mono closed, then you double clicked it, it would open mono and bring you right to that line. So 16 says something's wrong here. And you're like, what's wrong here? You'll click this and you'll see, oh, it didn't close there. So then you should just close it. And then the error will go away. So then the next thing that you're going to notice is you're going to notice these two things called voids. So use this for initialization, void start. And then update is called once per frame void update. So now everything that's with these kind of like double forward slashes like this. Make sure this is all still going. Yep. So everything that's with these, double forward slash is a comment. So if you do like, if you press enter, give yourself some new lines, and just comment, it's like this is my comment, and that's not code, and it won't get read as code, and it's just kind of like programmers use that to kind of like name things or to explain things in line with the code. There's another way to do this. If you need like a whole paragraph, you do /* and then you could type a lot of stuff, and then you close it with another /, and then this is all like paragraphs here you could write. So everything between a / and a star and a, it's kind of like, oops. They have to be together. If they're not together, then it doesn't count. So, yeah, and then everything in here is just paragraph. So this is a paragraph. This won't be read as code. So that part, and then yeah. So let's check out these void start and void update, right? So now void sounds like a scary word. What's a void, I'll explain why it's called a void. But void is basically the equivalent of function in C#. So if you've ever done any other programming, you've probably come across the word function or using functions. Void is like a type of function that doesn't return a value. That's why it's called void. And you'll see what I mean by doesn't return a value. But basically void start and void update are built into Mono behavior, built into Unity, and they give us some pretty useful things that we can do inside them, right? So what we're gonna do now is like on void start, I'm just gonna show you like a little just simple script that you can write. It would basically just outputs like a piece of text to this debug log here. So it's gonna tell us something. So the way that you do that is you type like this in start here. Between the curly brackets, you write debug with the capital D. And as you start typing, you're going to see that there's this kind of like autocomplete, and that's going to be very useful. So you do debug dot, and then capital L log. And you can see just as I type capital L, it's already auto-completing log for me. And then it also shows you what the structure of this is going to look like. So it's a void log, and inside a parentheses, you should have a message. So, and then there's a summary and explanation of what it does, logs message to the Unity console. So you'll notice in Unity and in MonoDevelop, everything that you're going to write in C# is going to have this amazing like autocomplete feature. I use it all the time. It reminds me what parameters go inside those functions, and you'll see that it's pretty useful as well. So you type log like that, and then you open parentheses, and then inside here, we're going to write a piece of text. Now, in order to write a piece of text, you can't just write text like this because it's going to think that's code. To write like an actual piece of text, you have to quote it. So you have to do a quotation mark, and then you write hello world. And you close the quotation mark again to end that string, and then you close the parentheses. And now the last thing you have to do to end this statement is do a semicolon. And the semicolon basically says that's the end of that line of code. Now you can do Command S and save. And you can go back into Unity. Now, on the sphere that we created, before we do anything, what I want to do is I want to rename this sphere, just so you know which one it is, and rename it to like move sphere or something like that. Should be fine. Just so we have a unique name for it. Okay. So now there's two ways you can add a component, like a script. You can click here, add component, and it's going to show you like a search bar, and you can just start typing ball move, which is our script, and there it is. And you can click that. Or you can drag and drop your script onto the object itself. whether it's in the hierarchy or in the 3D view. I wouldn't recommend dropping things in the 3D view because you might drop it on the floor, something else, and sometimes you might not notice that you have a script on the floor or something without actually looking. So the safest bet is to actually click the object that you want and go to Add Component and just type in the name of your script and then click it and add it. So when you have the script, you'll notice that now it shows up as a component, right? So now you'll notice that what you're actually doing is you're creating a custom component in Unity. That's how it all works. You can have multiple scripts on one object, and they all kind of come in as these components. So now that you have your ball move script, which is a component, onto the object, you can go ahead and press play in Unity, and then what you'll see is at the bottom of your screen it should say Hello World in the console. If you ever want to look at the console, you can always click right here in the project. You can click console. It's usually right at the bottom of Unity. So if your window is a little bit like below, you might not see it. But the console is going to be really useful to basically to debug, to see what's going on in your program that you might not be seeing in the code. So this is just a very simple kind of thing. Now, another thing that we can do is actually modify with this script some of the other components that are currently on our object. So when you're writing a script, the script doesn't know what object it will be on. That's your decision to take the script and put it on an object. But if you know that this script is going to be on an object that has a transform, which every object has a transform, you can safely assume that you can start moving this transform on start here. So here's how you do it, right? So again, the component here, you see that? It's called transform. Now, a quick shortcut to just reference the transform that we're like on the object that we're on, you can just start typing transform, like this, lowercase. I'll explain why it's lowercase. So just type transform dot position, and then you can do equals to, and then I'm going to introduce you now to a data type that's probably one of the most commonly used ones. It's called vector3, right? So vector3 is an X, Y, and Z data type. It basically just contains 3 floats, 3 decimals, an X, Y, and Z. That's all it is. Now, that vector3 can be used for position, for rotation, and for scale. All of those have an X, Y, and Z, and all of those are decimal types, floats. So, in order to create a vector3 to kind of place into this transform position, you have to do it like this. So, equals to new, and then it's with a capital V, vector3, like this. And then as you're typing it, it says summary representation of 3D vectors. And then you open parentheses, and now in here you can type in some white values. But for now, what we're going to do is going to do 0, 0, 0, like that. 0, comma, 0, comma, 0. And then close parentheses, and then semicolon. Save your script. And you can always check if your script is saved right on this little X. See if I type something, you can see how that X turned into a circle. So the moment you save, that turns into an X. So just so you know, that's like a quick way to just know if your script is saved or not. And you can go back to Unity, and if you press play, your ball should move to the 0 point. Whatever that is in your scene. Right, on start. So now you can see how like the script kind of can change a little component and do stuff. But what we really want to do is, we want to kind of move this on like a button press. So we want to move it, and we want to move it like incrementally. We want to move it by a certain amount. But before we do that, I want to just kind of show you just a few more tricks on this stuff. So Another thing to keep in mind, and again, some of this stuff might be a little tedious. When you're like, oh, how am I going to remember all this? Well, probably going to review the video, and eventually after doing it a couple of times, another 10, 20 times or whatever, you'll remember that this is how it's done. So if you want to actually place it in a specific point instead of 0, 0, 0, this is just a C# thing. I don't know why they do it like this, but they do it. When you put 0, you don't have to put this F. But when you put if you want to do 1.5, you have to do 1.5 F. Otherwise, it's going to say something like, you cannot put a double in a float. So when you don't put the F, that's an actual decimal, which in programming is called a double. But you pretty much never will use doubles. You will always use floats. The only people that use doubles or whatever are people that do back-end stuff, and the floats are too big for them. They're 8 bits instead of or whatever. I'm just making stuff up, but that's the only reason why someone would want to use a double and not a float. But you're always going to use floats. So always remember when you're typing in these specific numbers, and if it's a decimal, just do 1.5 F. 1.5 F, whatever. 1.5 F. So F is short for float, basically. And you can see, when I hover over this function, it basically, over the vector 3, it shows me vector 3 expects a float x, a float y, and a float z. Okay? So what's interesting about this, how the vector 3 has these parameters, right, is say we want to create, well, actually we could do this in a different way. Let's see here, what would be the next thing that's good to explain? So yeah, you could store, let's do it, why not? You could store this position value, you can literally set transform position to a new value, but you can also store these vector 3s in like a temporary value. So these are called variables. You've probably heard of variables. It's basically the equivalent of how we did high school math. X is equal to 0, y is equal to 2, x is a variable, solve for x, or whatever, So if we want to create place to store this 1.5, 1.5, 1.5, what we can do is we can just start typing the type. So the type is a vector 3, like this. And then the name of it is something like my position. And that could be anything you want it to be called. So anything that I'm going to name my position or my thing, or, it's just my naming convention. It could be, LOL, vector 3 LOL. It doesn't matter. It's whatever you name your variable is up to you. I definitely recommend you name it something that makes sense, because I did the LOL and variable LOL. It gets pretty confusing after a while. So vector my position, and then is equal to, and you can literally just copy this whole part here, new vector 3. So my vector 3 my position is equal to new vector 3, and then this. What that allows you to do is then you can make this transform position just equal to my position, semicolon. And basically, that's the exact same thing. But we're defining it before, and it's setting it after. Now, what this allows you to do, specifically with vector 3s, is now what you can do is you can actually go in, so right after this, my position has been defined, you can now start to get the values of my position. So you could do debug.log, like this, open parentheses, and you can just type in my position. So that will basically output this variable that you just wrote here to the console. So let's just try that real quick. Press play, and it should tell you something like, hello world, and then it, 1.5, 1.5, 1.5. You see that, right? So if you don't see it, you should just click console right here, right next to project. So did you type it in like this, debug.log? debug.log, my position. Semicolon. Yep. And save. So if you want to get specific, and again, like, you'll see how all this works in practice. Like right now, this is just theory. But my position, it's a vector 3, right? And a vector 3 has 3 components. It has an x, y, and z. So if you want to actually check what that is, here in the debug log, my position, you can actually do my position dot x, or dot y, or dot z. And it'll give you 1.5 instead of 1.5 comma 1.5 comma 1.5. So you can like drill down into that, and everything in coding, you'll see that it's something dot something deeper dot something deeper, and so forth, as deep as it goes, basically. So vector 3s only go this deep, so it's x, y, and z. So if you do dot z whatever and you debug that, you don't have to do it, but I'll just show you what happens. Instead of debugging the parentheses 1.5 1.5, it'll just debug 1.5, which is only that one value in there, right? So you'll see why this comes in handy. So now let's kind of try to play with some input stuff. Now, again, I'm going to explain kind of like what the start means and what update means, right? So start only runs once on start when the object is loaded in, and it'll run all that code in start, and it's done for start. So start is good for initializing and for doing some basic stuff. Depends on what you're really doing. Now for input, for like stuff like where I'm checking, where at any moment I could press W, or at any moment I can press enter, you need to always be checking for that. You can't just do it once on start, because on start it runs and it's not checking anything anymore. So that's where update comes in. So update is called once per frame. Now what that means is, so frames and frame rate, you probably might know what that already is, but in coding and in like a 3D engine, every animation, everything that you see moving on your computer is basically a sequence of frames. It's like 60 frames into a second are basically like a fluid motion that you don't even see the individual slices, but that's what creates it into a fluid motion. So update basically is called once per frame. So your computer, depending on the speed of your computer, it renders hundreds of frames per second. So everything you type in update will be done hundreds of times per second, basically, right? So if you do debug.log in there, like debug.log hello world, you don't have to do this, but just watch what happens, right? And I have the collapse on right here, which basically collapses the same message, but if I just turn off that collapse, you'll see that it'll just, see that? It'll just keep doing hello world forever. If you do the collapse, it'll collapse it, and then it'll just count the amount of time. Let's do it again. See that? My frame rate seems to be very low because I'm screen recording. That's why. But if you weren't screen recording, it would probably be in the thousands already. So that's where we want to check for a keyboard input, right? So here I'm going to introduce you to the first kind of like simple keyboard input, which basically introduces you to one of the most fundamental concepts of programming, an if statement. So if this, then that. So here's how you type an if statement, right? You just type if, and then space parentheses. And everything in the parentheses is if what, basically. So if, and then here's how you get a keyboard input, right? So you go into the input class, you type I, capital I, input, like that. And then dot, and then with a capital G, get keyboard key, or get key down. Let's do that one. So input get key down, same capitalizations like this. Usually in programming and the functions, every like word is like capitalized. So just to kind of like make the word separate. There's really no spaces. So that's why they do it with like capitalizing the individual words, so it kind of makes sense. Because if you type it like this, it kind of looks weird, doesn't it? Kind of hard to read, right? So that's why they do it like this. So input.getKeyDown, and then you can see right here what it expects. It expects a key code, returns true during the frame. The user starts pressing down the key identified by the key code. All right, pretty like straightforward. So input.getKeyDown, and then open another parentheses. So there's a nested parentheses. You have the first the if statement parentheses, and then the getKeyDown parentheses. And then in here, you could actually just, instead of using this key code, which is cool, but just for simplicity's sake, you could actually just do a quotation mark, and then the letter that you want. For this instance, let's do W. So just, and then close the quotation, close the parenthesis, and then close another parenthesis for the if statement, right? And then just kind of do the spaces like this so you can kind of clearly see it. Now, the parentheses work the same way as the curly brackets. If you hover, or like if you click on one of the parentheses, it shows you where it closes. So after this input, get key down, you're going to open a curly bracket right after it. And then press enter a couple of times to make some new lines. And then close a curly bracket. Now everything that runs between these curly brackets is basically only going to run if that's true. So if get key down W happens. So now let's copy our hello world into the if statement in there. Save your script and go back to Unity. Make sure on your console here, when you click right next to project, if you click console, just turn off the collapse for now. And you can always press clear to clear your log. But just uncheck collapse there. And now you can press play. Now in order for it to actually detect the key press, you have to be in the game view. So just to enter the game view, just click this area of the screen, and that basically lets the program know that you're in the game. And now press W. And you should see every time you press W, hello world will pop up. You see that? So now how does this translate to motion? So we're going to do just a simple motion. So let's try to like just put the ball like in the sky every time we press W, right? So here's how we're going to do it, right? So to get the ball's current position, we want to store the ball's current position. Now this is like, there's simpler ways to move objects, but why I'm going to explain it this way is just so you can kind of understand how to pull some data, change it, and put it back, basically. So what we're going to do is we're going to pull the ball's position, modify it, and then put it back into the ball's position. So here's how you do that, right? Just how we did it up there. You do vector 3, and you can call it ball position, something like that, is equal to transform dot position. So that's our current transforms position, which will be whatever it is in the Unity scene on the object that this script is attached to. In this instance, it's our ball. So vector 3 ball position is equal to transform position. Make a new line. Now you can do ball position dot y is equal to ball position dot y plus 1f. Does that make sense? So it's like we're taking the ball's position by using this transform position. So the transform position is this right here. See the transform? So when I click this sphere, see it has a transform, and that's its position. For me, it's like negative 0.19 0.53, whatever it is, you know. On your screen, it's probably different. Everyone's ball right now probably is in a different position, right? But that variable, that position is stored right there in the transform position. So we want to modify that. So the way that we do that is we take this data, we store it into a variable that we call ball position. And then what we're going to do is we're going to do ball position dot y, which is just that y, which is going to basically move it up and down, is equal to that same thing plus 1. So how do you increment by 1? You take the original value and you just add 1 to it. So that's why ball position dot y is equal to ball position dot y plus 1.
So earlier in start, we assigned my position to transform position, right?
Yeah.
So we can use my position to find out what the current position is maybe after you hit W.
So
is that how you would do it, or
yeah, well, the best way to find the current position is just to use the transform
just use
position.
transform because
That's
it's
always the
most current. or
that's the current
most
position.
accurate, right?
Yep. You can always just, if you just think about it in terms of the component that's right here, this is always the final like
Real
position.
time.
The real
Yeah.
position of the object is stored in transform, and then you can see right there's the position. So yeah, that's actually good. So I actually want to not move the transform position to that 1.5 because it just does it on start. We just kind of did that as a test. So you can actually comment out that piece of code right here just by putting 2 forward slashes in front of it. In front of transform position is equal to my position. And then that won't run. So we don't want to move it on start. We want to only move it on the W, right? So the last thing, so we have a ball position that's our like, think of it just like you're taking notes. Like you're basically just recording the current position. And then you're incrementing the y by 1 by just, this is just a very simple way to do it. Another way to do it, and this is a coding way to do it, is ball position dot y plus equals to 1f. So that's basically the same exact thing as ball position dot y is equal to ball position dot y plus 1. It's just a coding way to do it. When you do plus equals to, it basically just adds to the left side. The only reason why I did ball position dot y is equal to ball position dot y plus 1 is just to kind of try to explain it in like simple terms so it really clicks. I know it could take like a little bit to kind of wrap your head around this stuff, but once it kind of clicks, it clicks. So, but you don't have to use this plus 1. We can comment that out right there. You know, you could just keep that there just so you know that that's another way to do it. And then the last thing we have to do, so currently the ball hasn't moved yet because the transform position hasn't been set back to. We're only pulling from the transform position to see what it is and incrementing that. Now we have to take that thing we incremented and put it back into the transform position. So the way you do that is just in reverse. You just do transform dot position is equal to what? Ball position. Right. It's okay if this stuff, it's going to take a little bit, but we're going to do a few exercises like this, and you're going to see how it works, right? So that's it. So now if you go into Unity, make sure you save your script, make sure you put the semicolons everywhere that you need to, and you go press play, click in your game view, and when you press W, it'll do that. Now as you can see, it's obviously moving like that. Why is that? It's because we're incrementing by 1, which is a whole number, pretty much. Right? So probably not like the best way to move like for, you know, like some fluid operations. We're going to get to that. Just wanted to kind of explain how this works. Now you can do the same thing in all the other directions. All you have to do is instead of Y, you could put like something like Z. And then you're going to move it into Z. See that? Moving forward now. So just remember that everything has an X, Y, and Z. So
And I probably gonna, I'm sure you covered this, but we didn't apply any physics to this ball.
not yet. No,
Okay.
we're not even using physics. We're
Right.
literally doing like our own like very rudimentary.
But you can combine.
Physics. Yes,
Okay.
absolutely, absolutely. Yeah, we'll make it roll and all that stuff. Like when you get to physics, you just so you're not don't even worry like oh I gotta do rotations and roll. No, physics it all works with forces. So you'll just do add force, and then you just tell it which way you want the force in Z or in Y, and it will roll on its own like based on the force. So everything's forces and velocity when you start doing physics. But for now, I'm just trying to explain how to modify the
Yeah.
raw like data, like the X, Y, and Z stuff. So just for like reference, this stuff will be used basically in AR for stuff like knowing, we're gonna do like a little basketball demo. We're gonna need to know like where you're placing the hoop, for example, where in X, Y, and Z. So we'll do things like we'll check on the table what X, Y, Z that is, and then we'll say, okay, now place the hoop on that X, Y, and Z, for example. So that's the idea of it. And you'll basically modify the hoop like on start or something like that. It'll just put itself right there where you tell it to be, basically. And the reason why you need to know these positions is so you could place things in those positions. So we'll do a little thing that basically it's called a raycast. You'll see later. It's not as complicated as it sounds, but it basically shoots like a laser, like a line, and then it detects, okay, that's this X, Y, and Z. And you store that, and then you tell that thing to just go there. And that's all it is. It's like a very simple, like 2-3 step process. But yeah, you'll see how all this like translates to useful things like in AR and in VR. So we currently have this kind of incrementing, like very suddenly like this. What we want to do is, and I actually want to like rename this ball position because I think ball position might be a little confusing. You should rename this to my temporary position, something like that, and then just rename it everywhere else too. So that basically explains that this is like your temporary just position. It's not the actual ball's position. It's just something that you're working with. And then right above this, my temporary position equals the transform position. You could do 2 forward slashes, and I could just explain it right here. You could say, take the ball's current position and store it in my temporary position. Then the second line is take my temporary position y value and add 1 to it. 1/2 or whatever. And then the last one, transform position equals to my temporary position. Then you say set my temporary position back to the ball's current position. So I think that should like clear out any misconceptions. So now the other thing I want to do is I want to show you a little bit how a fluid motion would work. Now, get key down only runs once on when it's pressed down. It doesn't hold. So for a hold, you need to do get key instead of get key down. So it doesn't matter what you put in here, even though it's running every frame. Once you press it, it'll just run once. Until you release it and press it again, only then will it run again. But what we want to do right now is we want to like move the ball like this as we're holding. And when we release, it stops moving. When we hold, it keeps moving. So just to save this so you don't lose it, here's what I want you to do. So this whole chunk here, input get key down, right before it, I want you to do a /* just to comment out that whole thing. And then right at the end of it, you do a star and / to kind of just make that like one chunk there. I'm going to call that obsolete for now. I'm going to do a better one. So again, like, if you think back to school, early days of school, how did you learn all, the trigonometry? How did you learn like X and Y, parentheses, all that stuff? Repetition, repetition, repetition. Multiple examples. Word problems. That's how they drill it into you. It's like word problems. Sally had 5 apples. Josh had 4 apples. How many apples did they have together? And you're like, like 9. 9, teacher. Like, good job. So like we're gonna do a few of these kind of examples, but you'll see how progressively they'll just change slightly, right? So our problem is that we're incrementing in a very ugly way. We want to do it smoothly, right? So here's how we're going to do it. We're going to do if input dot get key. So it's no longer get key down, it's get key. And you'll notice as you're typing it, there's also a get key up, which is another very specific thing for only when you release will it run. So you can hold and still nothing, and then only the moment you release, it will do it. So sometimes that's also very useful. You want to like maybe make an object stop the moment you release or something like that. So for now, we just want input get key, and then open parentheses, and the same thing, quotation mark W, end quotation mark, close parentheses, close another parentheses for the if statement, and then open a curly bracket, make a few new lines, close the curly bracket. And that basically sets up our little if statement right there. So this makes sense, right? Why there's 2 parentheses that close at the end. Because one opens, then another one opens, then 2 close. So in here, what we're going to do a little bit different. So this is all still going to be the same. So vector 3, my temporary position, you can just copy and paste it from up there. Vector 3, my temporary position is equal to transform position. The difference is going to be how much we're incrementing by, right? So just as like a test, and just so you can see what it means to increment by 1 as you're holding, you'll see that it's going to be extremely fast. It's going to go up so fast, like because you're holding, it's like you won't even notice maybe how fast it's going to go. But let's just try it, right? So if we take the same code, my temporary position dot y is equal to my temporary position dot y plus 1, and then transform position is equal to my temporary position. Same exact code, right? Okay, everyone got that? Try it out. It'll fly right off your screen. Look at that. It's already gone. See how fast it is? Look at that. Very fast. Do you see that? You got it working?
Yeah.
Cool. So let's just for fun also. Well, actually, we could do making going down later. You could probably guess how to make it go down, right? Can you make it go down? Make another, make one that makes it go down on S. I want you to do that. So get key S and make it go down too. And then when you're testing it, you can make it go up and down.
Wait, so are we changing this one or adding?
You're adding another one, so you want to make one that goes up and go down. So really good function makes it go down.
I could do minus equal.
Yep. Good. Yep. Try it out. Save. Make sure you save. Simple, right? Once you kind of get the logic, you'll see that this stuff is pretty simple. So yeah, if you hadn't guessed, which you both did guess, you just copy and paste the whole code block. You only change the W to an S, and you change the plus to a minus. And that's all it takes. Up and down, up and down.
We have an error and define
You might have put some curly brackets somewhere.
an extra one.
Either an extra one or not enough. Oh yeah, so you're missing. Yeah, so you need to add one more at the end there. So if you copied and pasted from here, but you forgot to paste in that one. Yeah. So you should add just. So don't put it at the end here. 'Cause these are, see, this one kind of like is this one, and then this one is actually for this one. So you kind of want one like here. Always kind of like just, that's how the indents work.
Okay.
It's just to keep it like kind of clean. It would work if you put it at the end, but it would work, but it can get a little confusing. So it's good to kind of keep them like that. Now, how would you make it go slower?
Reduce the increment number.
Make it go slower. Slower. Good. Makes sense, right? So you see, it's just math. You can make a decimal. Yeah, just make sure you do that F. Now, this is also a good time to kind of like explain. So, since we're kind of going in the same speed up and down, right? It's a little redundant to type +1, -1, right? What if you want to just change the speed in one place and just change it across all of them, right? So here's how you do that. So all you have to do, and this is a good place to introduce the float type. So right above both of these, you can just type like this: float my speed is equal to something, whatever you want it to be, like 0.5 f or whatever your slower speed was. So float my speed is equal to 0.5 f. Right above here. You have to say float because you're defining it. This is going to be a float. And now, instead of doing +1f, you do plus my speed. And instead of -1f, you do minus my speed. Also, yeah, make a semicolon. Sorry, I didn't do that. So now, instead of changing it in code there, plus this, minus that, you can just change right here where it says my speed. You can change it there, and it will change it in both of these places. Try that out. Good. Okay. Now, I'm going to show you another really cool Unity feature and how that my speed can actually look pretty cool, right? So, since this float my speed is just inside this update, it's what's called a local variable. So it's a temporary variable, my speed. You're just kind of, it doesn't really get like, doesn't exist outside of this little code block. It's just kind of there. But in order to make something exist outside, like, and you can see it like in the Unity inspector, you can copy just this whole statement here, float my speed, and after you copy it, just delete it or cut it or whatever. And then I want you to scroll up to the top, right before void start here, and paste it. So float my speed like that. This will work, but I want to add one more specific thing. So yeah, just make sure it's inside the class, but outside of any of these voids. It doesn't have to be at the top. It could actually even be here, right above update. That works too. But I just have like a good rule of thumb to just keep all of the public variables, which I'm going to explain what that is, here at the top. So we're going to make this into something that's called a public variable. So right now it's like a private variable. It's just kind of like inside our little code block. And I'll explain right now what a public variable advantage is, right? So right before float, you just write public. And you make it a public float. Anything can be public. It can be a public string, a public this. So if you save that, go back into Unity, click your move sphere, and just take a look at your component now. What do you see? Yep, which is your own defined variable. And you can now change my speed right from within Unity here. So try that. So right on the fly, press play, move it around a little bit, then change the speed and move it around some more. But you have to press enter after you change the speed there. So now you're writing a custom component. And you're putting your own variables outside for you to be able to modify it. You see that? That's where that really comes in handy, that like storing a variable in a, like outside, is because then you don't have to go into the code and tweak the speed. Like say you have the speed not just on two, like W and S, but on A and D. So you have left, right, up, and down. And then maybe you also have speed on some other variables or whatever. And maybe you're just testing and tweaking stuff. You don't want to like go in and just write it in 4 places. You just write one variable, put it in all the 4 places, and all you have to do is change that one variable. It's like solve for x. Change x, and x changes in everywhere where x is referenced, basically. Or y, or whatever. Now, even though this works, and you know, if it goes too fast, you could just reduce the number. But again, I'm going to explain this, like it might go a little bit over your head, but I'm going to try to kind of bring it in with like an example from back in the day, right? So when like you had Super Nintendo, Sega Genesis, like back in the day, right? Coders knew exactly what they were coding on hardware-wise. So all the hardware was the same. My Super Nintendo and your Super Nintendo and every Super Nintendo in the world ran the exact same processor, graphics card, everything was exactly the same. There was no like supercharged Super Nintendo. They were all exactly the same. It would actually break the game if you made the Super Nintendo faster. So basically the coders could just, if they wanted something slower or faster, they could just lower the speed and it would be the same across all the devices. this is not just for Super Nintendo. This was for Sega. This was for all the consoles, even up to the recent ones. Where like basically the coder knew exactly what the hardware was running on, and he was testing on. He was doing production on the testing hardware. Basically, it's the same thing. So like, it never changed, right? But in today's world, what you're coding in Unity will possibly run on many different devices, different phones, different operating systems. My phone and your phone, my phone might have like a background service running that's slowing my phone down more than your phone. Even if they're the same phone, users have different like ways of using them. And in essence, what I'm getting to is that today's devices have a variety of speeds. And you as a programmer have no idea what speed it's going to run on. Someone might pull up a really old Toshiba laptop and try to run your experience, which on your Mac is running, at a certain speed, but on their Toshiba laptop, it's going to run much slower. So that ball is going to go also much slower with the current code that we have right now. Now, luckily, there is a little trick that you can use, which basically is a little like number that counts like how fast your CPU is calculating per second or something like that. So on all of our laptops right now, this ball, even though we might not notice it, and if we all make it the speed the same, 1 or whatever, it's probably going to go at a different rate. Like if you have like a finish line, like my laptop, since it's probably screen recording right now, mine would finish last, for sure. Yours would all finish first or second or whatever. And if you think about it, like if you're making a game or something, that's pretty unfair. You can't do that. Like, so the way that you fix that is this my speed, where you're doing plus my speed, you do times, so my speed times, and then you start typing with a capital T, time dot delta time. So that's that. Time delta time is the amount of milliseconds or whatever that it takes for your processor to calculate 1 frame. Which basically, by multiplying the speed by that, again, like this is like, a little higher level math. It's not that high level, but it's still like, it might be a little hard to wrap your head around it. But just know that like, if you want to sync across like whether a device is fast or slow, you should be multiplying by this time delta time, and then it will make sure that even if my CPU is choppy right now, it will still reach the finish line at the exact same time if we're all holding the button at the same time. So my speed times time delta time on both of them, on up and down. And now what you might notice is when you go into the program and you try to run it, your ball is going to go so slow. So slow. Like so slow. But it'll go at the same rate for all of us. Doesn't matter how fast or slow our computer is. What you do to make up for this is now your my speed no longer needs to be 0.5. Now it could be something like 10 to make it what it was before. Get it? So when I asked you before, like, how would you make it slower because it was too fast, that was kind of like a trick question. Yes, you can just lower the speed, but that's not the correct way to do it. The correct way to do it is to multiply it by time delta time to get the actual incremental speed that you need, and then you set your my speed to whatever is appropriate for your screen or for your preferences. Does that make sense?
So times time delta time is the equalizer. For
The equalizer.
everybody,
Yep,
right?
exactly.
So delta time is how it figures out what the local machine's processing speed is.
Yep.
And normalizes that for
Yep.
the game.
Exactly. So I know some people maybe try to explain that and they don't really have much luck explaining it. I have a lot of luck explaining it with the Super Nintendo example and stuff because it makes sense. Like they didn't have to use time delta time back then. It was just a value and that's what it was.
Right.
But today everyone has to use time delta time because you don't know.
Because we're all the collaborative games, the ones where you're all online,
Multiplayer and
the
stuff.
multiplayer ones are where you're gonna notice that kind of
Yep.
disadvantage. Right?
Absolutely. So
Does that mean if you have a slower machine, then your delta time is gonna be faster because your I guess your processing power is a lower number, so your multiplier is higher.
something like that. Yeah. I think like
I
you
mean,
could,
would
you could
it-
always output time delta time in a debug log and
Right.
just kind of see. But yeah, I think that's how it works.
Yeah.
You got that right. We can actually check right now because my computer is definitely the slower one right now.
Oh, and it also has to figure out what's being used too. It's like the current power, right?
Yeah. So if I output my delta time in debug log on start, my delta time is 0.02. So what's yours? Just on start, make it a debug log, just like this, time delta time. What is it?
102.
Same thing? Mm. What if I do an update? Yeah, it changes. Yeah,
Yeah.
it's a variable.
It's probably just at the beginning. It starts that way, right?
Yeah. If you're doing an update, mine's hovering between like 0 point. I mean, it kind of goes up and down. That's the thing because the CPU and everything, it's not always a constant like speed.
Yeah.
Too. Depending on what other stuff you have running. But yeah, I'm glad I could explain that. That takes some time to sometimes to wrap your head around, but sometimes you go like, "Why do I have to do this?" But yeah, so also the other important thing is again, this is just order of operations. Multiplication comes first, so whatever you're adding here, it knows. So it will first multiply this, then it will add this.
Mm-hmm.
So just know that order of operations still stands in coding. Parentheses, take precedence, things like that. So if you really wanted this to be plused first and then timesed, which would be completely wrong, you would, parentheses it, and then this will actually get added, and then it will get multiplied. So, but if you don't do that, then it will just go for the, classical order of operations, multiplication first, then addition, subtraction, and etc. So, all of that still applies. Yeah, so this is like the basic stuff, just kind of like the get key stuff for just transform position. I guess we could take a little break and then we'll get into physics.